Hi there, I just wanted to do a quick video to introduce a couple of linear rails I'm thinking of using on a 3D printer, and what I haven't been able to find is a comparison between the high quality Hiwin linear rails that come with, for example, etched rails, and when this focuses you'll be able to see. Okay, so you can see the etching on the rails there, and you get a nice carriage. Comes in its own separate packing there, and you can see it's got its own etching on that as well. And I wanted to compare that to this kind of thing, which is a Chinese clone from a company called Robotdigg, and they say this is their high quality stainless steel version. Now what I've gone for is the 9mm version, and I've gone for the longer carriages as well, because I think that's going to give me better stability during changes of direction. Now they say it's stainless, and both of these are supposed to have stainless rails, but both of them are magnetic. There's a little neodymium magnet, and that attaches to both. So if you get the Robotdigg one and you think, hang on, it's not stainless because it's got a magnet is able to stick to it, well, that's also the case for the Hiwin version. So turning first to the Hiwin rails, it comes in this little packet with the Hiwin tear-off seal on the top, and then we get the carriage itself is on a little plastic bearing keeper. So to put it on to the rail, you have to line up the bearing keeper and with the rail, and then gently slide your carriage onto the rail. Now when I first bought this and put this on, I found that there was some friction problems with this. I went back to the seller, and I'll put a link down in the description below, and they said, well, try some oil. I've done that, and actually I don't know whether it was the oil or whether it was just giving it a bit of a run in and lots of motion backwards and forwards, and it seems to have settled itself now. So I'm quite happy with that. It's very smooth. It actually feels, although I can't feel any play by hand, it actually feels almost loose. When you get it also, bear in mind that there's nothing, I've got two M3 bolts in the end here, but there's nothing to prevent the carriage from coming off, so you've got to be really careful that it doesn't just fly off. Whereas turning to the Robotdigg high quality stainless steel version, you do get these clips at the end. It comes with the carriage already on it, and they haven't scrimped on packaging either. That was a not vacuum wrapped, but certainly well sealed unit that comes from them, and they use decent packing as well, with a nice sort of stiff cardboard tube to protect it. In terms of dimensional similarities, the spacing on the on the centres for these, so let's just do edge to edge, it appears to be the same. Now I haven't tried it with anything more accurate than just doing an eye edge to edge, but as you can see, these look like the carriages are meant to accept the same bolt spacing parts. And again, if you look on the length of the carriage, they're designed to be the same. I think we'll see about less than 0.5 mm difference there. In terms of the seals, one thing that I've seen online is that people say with the true Hiwin stuff you get a decent rubber seal on the end here. Well, I have to say that these Robotdigg ones also come with a soft rubbery material on the end seals there. Now, turning them over, let's have a look at the bearings, if I can get the focus right and the lighting right. You can see in by eye, I'm not sure it shows up on this video, the steel ball bearings inside, and you can see the way they run. and it's the same on the Hiwin. Again, you've got some engraving on the base of the carriage. Again, not sure if you can see the bearings on that. The Robotdigg carriage is a little tighter feeling. It didn't come with that initial lumpiness of stiction. However, even after a few rapid runs up and down, it hasn't loosened off and doesn't quite have the same freewheeling feel to it that the Hiwin does. Now again, on the tilt test, you can see you don't have to raise the angle too high on the Hiwin for under its own weight, overcoming stiction and friction and sliding to the other end. You have to go quite a bit steeper, and even then, let's get it started. Yeah, and it goes. So it's the stiction really on the Robotdigg version to start with, but none of this really tells us a huge amount about how well these are going to perform in a dynamic loading scenario, because what my fingers won't be able to tell is the kind of deflections that these carriages and rails are going to show under changes of direction of the 3D printer. I've got a Core XY in mind, and this Hiwin is destined to be the X gantry rail, and I'm going to have two of these for the Y axis rails. In terms of rail dimensions, they're broadly comparable, although I haven't tried sticking each other's carriage on each other's rail, but there is about a 0.5 mm increase in height on the Hiwin, and that's the only dimensional difference that I can tell from a quick look at them. So I'm going to leave it there for now. I'm going to try and do some tests to work out what kind of deflections we'll get under loads, and I'm going to use some static experiments to do that rather than dynamic ones to start with before attaching it to the printer, just to see whether there's anything noticeable, and also might see if we can check out whether the friction is noticeably different from a little test. But the main bit is to try and see whether some torquing in that kind of direction is going to end up with some significant deflections which might mess up the finish on a 3D print.